Today I am going to solve one numerical problem on viscous flow through a pipe. So here is the problem statement. An oil of viscosity 9 poise and specific gravity 0.9 is flowing through a horizontal pipe of diameter 60 mm. If the pressure drop in 100 meter length of the pipe is 1800 kilonewton per meter square, determine the rate of flow of the oil, the center line velocity, the total frictional drag over 100 meter length, the power required to maintain the flow, the velocity gradient at the pipe wall, and the velocity and shear stress at 8 mm from the wall. Now here step 1, viscosity and area. Here given data are viscosity of the oil mu, that is 9 poise. So if I convert 9 poise to Pascal second, so 9 divided by 10, so that is 0.9 Newton per meter square second or Pascal second. Specific gravity of the oil that is given, that is 0.9. So density will be 0.9 thousand, so that is 900 kg per meter cube. Then diameter of the pipe, that is D, is 60 mm. So if I convert mm to meter, so 60 divided by 1000, so that is 0.06 meter. Calculating the cross sectional area of the pipe, that is A, so here the diameter is given, so we can easily calculate cross sectional area of the pipe. So A is equal to pi d square by 4. So pi 0.06 whole square by 4, that is 0.002827 meter square. Now first rate of flow calculation. So pressure drop is given. Pressure drop is 1800 kilonewton per meter square. So that is nothing but 1800 into 10 to the power minus 3 Newton per meter square. Length of the pipe is given, that the length is 100 meter. Now using Hazen-Poiseuille's equation to calculate the average velocity U bar. So that is del P is nothing but 32 mu U bar L by D square. Now del P is given, mu is known, L is known, D is known. We can easily calculate U bar, average velocity. So that is nothing but del P D square by 32 mu L. So del P is 1800 into 10 to the power minus 10 to the power 3 into D square is 0.06 whole square. 32 mu is 0.9 into L is 100 meter. So that will, the average velocity is 2.25 meter per second. Now calculate the rate of flow Q. So Q, you can easily calculate. Q is nothing but area, cross sectional area into average velocity. That cross sectional area we know, that is 0.002827 into 2.25 that we got from the earlier calculation. So that Q will be 0.00636 meter cube per second, and if I convert meter cube per second, so that will be 6.36 liter per second. So we know that 1 meter cube is equal to 1000 liter. So we can easily calculate the meter cube to the liter per second. So here that Q is nothing but 6.36 liters per meter second. Now from that we earlier got that average velocity. From there we can easily calculate the center line velocity. So here center line velocity, that U max. So if this is the pipe, so this is the center line. So U max is nothing but 2 into average velocity. So average velocity got 2.25. So 2 into 2.25, that is 4.5 meter per second. Now next is total frictional drag calculation. So first we have to calculate the shear stress. So we know that dp by dx plus 2 tau 0 by capital R is equal to 0. From that we will get tau 0 is dp by dx into R by 2. So here that dp by dx is nothing but p1 minus p2 by L. So from here we can, the dp by dx we know that that is 1800 into 10 to the power 3, L is 100. So 18 triple naught Newton per meter square. So tau 0 will be 18 triple naught into 0.06 by 2. So that is 270 Newton per meter square. Now frictional drag over that 100 meter length. So this is the shear stress. Now if I multiply and that cross sectional area, we'll get the force. Okay, frictional drag. So tau 0 into pi dl. So 270 into pi into 0.06 into 100. So that is 5089 is the drag force. So now after getting the drag force, we can easily calculate power required to maintain flow. So P is nothing but that drag force into velocity, average velocity. So that will give that, if I substitute the value, FD is 5089 and U is average 2.25. So P will be 11.45 kilowatt. So now alternatively we can also calculate the power. So power can also be calculated using that pressure drop. So mass that volumetric flow rate into del P. If I multiply that, so we also can get the power. So that 0.00636 is the Q, volumetric flow rate, and del P is, that is 1800 into 10 to the power 3. So that is 11.45 kilowatt. So power required is 11.45 kilowatt. Now we can also calculate the velocity gradient at the pipe. So du by dy is nothing but tau 0 by mu. So from the Newton law of viscosity, tau 0 is mu into du by dy. So from here, du by dy at y is equal to 0 at the wall, that is tau 0 by mu. Tau 0 we got, that is 270 Newton per meter square. Mu we know 0.9 Newton second per meter square. So from here we can get the velocity gradients at the wall. So that is 270 by 0.9. So 300 second inverse. So the velocity gradient at the pipe wall is 300 second inverse. Now velocity and shear stress at 8 mm from the wall. So we know that local velocity is equal to 1 by 4 mu dp by dx capital R square minus R square. Now here, so this is the center line, and if I take that small cubical, the cylindrical element, so that distance is nothing but that y, this is capital R and this is smaller. So y is not that, R is nothing but capital R minus y. Y is given because from the wall to some distance, that is 8 mm. So that is 8 mm means 0.008 that meter. R is R minus y, so that is 0.022 meter. So now we can plug all this value, 1 by 4 into 0.9, then dp by dp, so that is 1800 into 10 to the power 3, and then R square is that 0.03 square minus R square. So we got that 0.022 square by 100. So we'll get U at 8 mm from the wall, so that is 2.08 meter per second. Now similarly we can easily calculate the shear stress. So we know the formula, tau by tau 0, so R by capital R. So we know all this, so we can easily calculate tau. Tau is smaller into tau 0 R. Smaller is 0.022, that tau 0 is 270, capital R is 0.03. So we can easily calculate the tau. Tau is 190 Newton per meter square. So velocity at 8 mm is 2.08 meter per second. Shear stress at 8 mm is 190 Newton per meter square. So finally, these are the summary of the calculation. So rate of flow Q is nothing but 0.00636 meter cube per second or 6.63 liter per second. Center line velocity Umax is 4.5 meter per second. Total frictional drag is 5089 Newton. Power required P is 11.45 kilowatt. And velocity gradient at the pipe wall is 300 second inverse. Velocity at 8 mm from the wall, that U8 mm, that is 2.08 meter per second. Shear stress at 8 mm, that is tau is equal to, the tau at 8 mm, and that will be 198 Newton per meter square. That's it. Thank you.